Hello everyone and welcome back to our discussion about mixed partial derivatives. In today's video, we'll be discussing more examples aside from what we have discussed in part 1 of this video. So the first example here is a given function with 3 independent variables, and the requirements here are we need to show that f sub xyz is equal to f sub yxz and equal to f sub z yx. So the first thing that you should do is to find first the partial derivative of a given function with respect to the first independent variable given. So the first independent variable given here for f sub xyz is x. So in other words, we need to find first f sub x. So we will find the partial derivative of this given function with respect to x. And with respect to x, this is equal to 3x squared y to the fourth plus 3x squared yz squared plus 12x squared z to the fourth. And afterwards, when you have this f sub x now, you need to find directly the next independent variable in the given. After x here, the next independent variable is y. So you will find f sub xy. So you will not be using the original function here, but instead you will be using the value of f sub x to get the partial derivative of f sub x with respect to y. And with respect to y, this is equal to 3x squared 4y cubed plus 3x squared z squared plus 0, because in the last term here there is no variable y here. That's why the partial derivative of this last term will become 0 because it is considered as a constant. So simplifying here, this will be equal to 12x squared y cubed plus 3x squared z squared. Okay, so that's the value of f sub xy. And then after that, we need to find the partial derivative of f sub xy with respect to the last independent variable given here. And the last independent variable here is z. So this answer here, we will find the partial derivative of this expression with respect to z once again. So with respect to z, the first term here has no variable z. So therefore, it will be a constant, and the derivative of the constant will become 0. And in the next term here, 3x squared z squared, so this will be equal to 2z 3x squared, or simplifying, this will be equal to 6x squared z. So this is now the value of f sub xyz. Our next step here is to find the value of f sub yxz. So we need to start first with f sub y. And to find f sub y, we'll be using the original function here, which is equal to x cubed 4y cubed plus z squared x cubed plus 0. Simplifying, this will be equal to 4x cubed y cubed plus x cubed z squared. And then after that, you will find f sub y x, because in the given requirement here, the next independent variable after variable y is variable x. So this answer here, we will find the partial derivative of that with respect to x. And with respect to x, this will be equal to 12x squared y cubed plus 3x squared z squared. And finally, we will find f sub yx z, because the last independent variable here is z. So this answer, once again, we will find that partial derivative with respect to z. And with respect to z, the first term here, there is no variable z here, so that will become 0, plus with respect to z, this will become 3x squared 2z, or simplifying, this will become 6x squared z. So this is now the value of f sub yxz. And lastly, we will find the last requirement here, which is f sub zyx. So the first thing that you should do is to find first f sub z. So f sub z, using this original function here at the top, that will become 0. There is no variable z in the first term here, so that will become 0. 0 plus 2zx cubed y plus 4x cubed 4z cubed. Simplifying, that will become 2x cubed yz plus 16x cubed z cubed. And after that, we'll find f sub z y, because the next independent variable here is y. So we'll find f sub z y. And f sub z y is obviously equal to 2x cubed z plus 0. There is no variable y here in the second term, so that will become 0. So the answer here will become 2x cubed z. And finally, we'll find f sub z y x. The last independent variable here is x. So we'll find the partial derivative of this answer here with respect to x. And with respect to x, there is only one term here. So with respect to x, that will be 6x squared z. And did you notice that all of the values here are equal? Okay, so f sub xyz is 6x squared z. Same also with f sub yxz, which is 6x squared z, and the last here. So therefore, we can say that we were able to show that f sub x sub yz is equal to f sub y xz and also equal to f sub zy x. I hope you understand that. Here in the second example, we are given u equal to the ln of the quantity of x squared plus y to the fifth power. And we will show that u sub xy is equal to u sub yx. This equation here appears to be a mixed partial derivative because it's a combination of xy first and then yx. The given function here is u of the ln of the quantity of x squared plus y raised to the fifth. So this is ln. And I would like to reiterate in calculus 1 that the derivative with respect to x of ln of u is equal to 1 over u du dx. However, in our lesson here, we are not dealing here with one independent variable. So, in other words, what is the partial derivative with respect to x of ln of u? That is 1 over u times the partial derivative of u with respect to x. And the question here is, what is the value of u in the given problem? The value of u is the term or the expression inside the parentheses, and that is x squared plus y squared. So we will let here u equal to the expression inside the parentheses, which is x squared plus y to the fifth. And what is the partial with respect to x of this expression x squared plus y to the fifth, because that is the partial derivative of u with respect to x. With respect to x, that is equal to 2x plus 0, or that is equal to 2x. So that is the partial derivative of u with respect to x. And what is the partial derivative of u with respect to y? With respect to y, and the partial derivative of u with respect to y, so that is equal to the partial of x squared plus y to the fifth with respect to y, so that will become 0 plus 5y raised to the fourth, or that is equal to 5y to the fourth. This is the partial of u with respect to y, and this is the partial of u with respect to x. So going back to the requirement, the first requirement here is u sub x. So in other words, we will find here u sub x, okay, with the original given function ln of x squared plus y to the fifth. U to the x is equal to 1 over x squared plus y to the fifth power, that is the value of u, and then we'll multiply that to the partial derivative of u with respect to x, and that is equal to 2x. So we'll multiply this by 2x. Okay, so that simplifying, this will be equal to 2x over x squared plus y to the fifth. And our next job here is we will find u sub xy. So this answer here, we will find again the partial derivative of this expression with respect to y. And with respect to y, this will be equal to the partial derivative with respect to y of 2x over x squared plus y to the fifth, which is equal now, this is a combination of chain rule, to 2x times negative 1 times x squared plus y to the fifth raised to negative 2 times the derivative of the inside function, which is 5y to the fourth. because we are differentiating with respect to y. So x squared will become a constant, that will become 0. So the derivative of the inside function here will become 5y to the fourth, or that is the partial of u with respect to y. Simplifying, this will be equal to negative 10xy to the fourth over x squared plus y to the fifth raised to the second power. Okay, so that's the first part, and I will move on to the next slide to demonstrate to you the value of u sub yx. Continuing the process here with u sub y, then u sub y will be equal to 1 over x squared plus y to the fifth power times the partial derivative of u with respect to y, and that is equivalent to 5y to the fourth. And then we'll have u sub y with respect to x, and that will be equal to the partial derivative of, so this is equal to 5y to the fourth power over x squared plus y to the fifth power. So to get u sub yx, we need to get the partial derivative of this answer here with respect to x, because we are looking for u sub yx. So u sub yx now is equal to 5y to the fourth power times negative 1 times x squared plus y to the fifth power raised to negative 2 times the derivative of the inside function with respect to x, which is 2x. So this will be equal to negative 10x y to the fourth power over x squared plus y to the fifth power raised to positive 2. Therefore, we can say that u sub xy is equal to u sub yx. And that's it for example number 2. Here in the third example, this is a different example because we are given here a function, and the requirement is we will verify if this equation will be satisfied with u sub xx plus u sub yy is equal to 0. So the first thing that you should do here is to find u sub x and u sub y. So u sub x is equal to the partial with respect to x of the given function e to the x sine of y plus e to the y cosine of x. A little note here that the derivative of sine x is equal to cosine x, and the derivative of cosine x is equal to negative sine x. So in other words, going back to our solution here for u sub x, then this will be equal to e to the x sine of y plus e to the y times negative sine x. And simplifying, this will be equal to e to the x sine of y minus e to the y sine x. Okay, so that is the value of u sub x. And u sub x will differentiate with respect to x once again this answer. So this will become now e to the x sine of y minus e to the y cosine of x. That's the answer for u sub xx. And then we need to find also u sub y first before u sub yy. So u sub y is equal to e to the x times cosine of y plus e to the y cosine of x. And then u sub y u sub yy is equal to e to the x times negative sine y plus e to the y cosine of x. Simplifying, this will be equal to negative e to the x sine y plus e to the y cosine of x. Okay, so that is the value. Now we are very ready to check the equation, and we will verify if this is the question. U sub xx plus u sub yy. The question is it equal to 0? So we will substitute here the value of u sub xx, which is this one. This is the value of u sub xx. and it's the value of u sub yy. Okay, so u sub x is e to the x sine of y minus e to the y cosine of x plus the value of u sub y is negative e to the x sine of y plus e to the y cosine of x. The question is it equal to 0? Obviously, what do you think? There will be cancellation that will happen here, especially this one. This is positive, this is negative, and this is negative, the whole of this, and this is positive. So therefore, what can we say about the answer? We can say that 0 is equal to 0.